so far this triad, we've looked at solving a lot of different kinds of equations. We started out the year in August solving one-step equations. And then this triad, what we've done is we've gone beyond that and we've solved two-step equations and then three-step, four-step, multi-step equations. We've solved equations with variables in different places. We've solved some equations with square roots in them. And this is the last type of equation that we're going to see before the end of the semester. All right, so what we're going to see now is equations with squares in them. So this right here should say, instead of square roots, it should say solving equations with squares. And so what we're going to do with this type of equation is actually exactly the same thing we did with square roots with one small difference. Because we're not trying to get rid of a square root anymore, now we're trying to get rid of a square. So what's the difference going to be? To get rid of a square root, what do? We square it. So to get rid of a square, what are we going to do? We're going to take the square root. All right, so we still use the idea that squares and square roots are opposite of each other. And now we're going to do that, or use that, to get rid of a square instead of a square root. So the first thing we're going to do is we're going to use the golden rule to get the square by itself. Now, just like when we were solving equations with square roots, since we want to get that square by itself, we're going to box the square in an equation also. So we're going to put a box around that square when we see it, so that we know we have to get that square by itself first, and then we can get rid of the square, and then we can do other stuff. All right, so the first thing we're going to do, we're going to get that square by itself using the golden rule. Once we do that, then we're going to get rid of the square. So to get rid of the square, as Jasmine said, we want to take the square root. So we're going to take the square root of both sides of the equation. This is the only difference between these types of equations and the ones with square roots in them. So now we're going to take the square root to get rid of the square. And then once that square is gone, we can just solve like we normally do. Now I want to point out one more time, and I'll mention this probably when we do a few of the examples also. When we take the square root of both sides, we're actually going to get two answers at that point. We're going to get a positive one and a negative one. For now, we're only really going to worry about the positive ones. But I want you to keep in mind that there really will be two answers to these problems. One of them will be the positive one when we take the square root. One of them will be the negative. But we're not going to worry about the negative one. We're just going to stick with the positive one for now. Let's jump straight into some examples here. This is a pretty simple one. We have a squared equals 25. First thing we're going to do is circle a variable. Draw a line through the equal sign. With this problem, we don't have to do it, but I'm going to go ahead and do it anyway. I'm going to put a box around the square. Now, the reason I put a box around the square is because I can't get rid of that square until the square is by itself. But what's happening in this problem? The square is already by itself, right? So in this problem, you don't have to put the box because the square is already by itself. All right, so what am I going to do to get rid of the square? How do I get rid of a square, Levante?
Square root.
Take the square root. So I'm going to put a square root over my square. That's going to get rid of the square. And if I take the square root of the left side, then I need to do the same thing on the right side. So I'm going to take the square root of the right side. Now, most of the problems we're going to do when we take the square root over here, it's going to be a perfect square. So we're just going to get another number. But what if we had a number like 360 over here and we were taking the square root? What would we have to do? Can we take the square root of 360? That's the one we had in the opener, right? Aiden? Yeah, you would have to factor it, circle the pairs, pull the pairs out front. So you would have to simplify the square root. So if it's not a perfect square, you'll need to simplify the square root. All right, so on the left side, what's going to happen with this square and this square root? They're going to cancel each other out. And what's left? The a. And on the right side, the square root of 25 is 5. Now, there is another answer that will work here. what other number could I put in here for a that would work? Somebody besides Aiden. Jasmine? Negative 5. Because negative 5 squared means negative 5 times negative 5, which gives us positive 25. So really, a could be positive 5 or it could be negative 5. We're just going to worry about the positive one. Okay, next one. We've got 3 equals b squared minus 1. Again, we're going to start by circling a variable, draw the line of equality, and one more thing here. Put a box around that square. Okay, that's a reminder that I need to get that square by itself. We box that square because we want to make sure that we get the square by itself first, which means I need to get rid of what first? Kayla? So since we want to get the square by itself, I need to get rid of anything that's outside of the box first. This is the same thing we were doing when we had equations with the square roots. We have to get rid of everything outside the box first. So we're going to get rid of that minus 1 by adding 1. And simplify each side. On the right side, we're going to have the b squared. On the left side, we're going to have 3 plus 1, which is 4. Now the square is by itself. So what? What do I do next? Scott? Yes, we want to get rid of that square, so we're going to take the square root. Now, if I take the square root on the right side, I have to do the same thing on the left. All right, so on the right side, the square and the square root cancel each other out, which leaves what? The b. On the left side, 2. Or it also could be what? Yeah, it could also be negative 2, but we're not worried about the negative one. Does anybody know how I would write that to show that it could be positive 2 or negative 2? You don't have to do this, but this is just something you may see later on. You can put a plus or minus sign out front here. So what this symbol means right here is it could be a positive 2 or it could be a negative 2. We're not going to use that. But if you see it, that's what it means. It could be either one of those. Next one, example 3. We've got d minus 4 in parentheses and then squared equals 25. So again, we're going to start by circling the variable, draw the line through the equal sign. Now the trick here is to recognize what's squared. Is this square on the d? Or the 4? It's actually on the parentheses, right? So the square is on the parentheses, which means that this whole thing right here is a square. Since this whole thing right here is being squared, can I get rid of the minus 4 right now? No. Why not? Because it's in the square, right? So before I can get rid of that minus 4, I have to get rid of the square by doing what? How do I get rid of a square? Take the square root. Square root cancels the square out. All right, so that whole thing is being squared, so we take the square root of that whole thing. The whole square. Now if I take the square root on the left side, I have to take the square root on the right side. All right, so on the left side, what do I get when that square and square root cancel each other out? What's left? D minus 4. And on the right side, the square root of 25 is 5. It also could be negative 5. All right, but like I said, we're not worried about that. Now, I just need to get the d by itself. This is a pretty easy one, right? What do I do? Add 4 to get rid of the minus 4. Those 4's cancel each other out, so we get d on the left side and 9 on the right side. We won't mark it wrong if you put the negative answer in there also, but I will tell you this one's a little tricky because negative 9 does not work. So right here, if we think about what the negative answer would be, this also could be a negative 5. So what we would have is negative 5 plus 4. So the other answer that we get from our negative would be whatever we get when we do negative 5 plus 4, which is what? What's negative 5 plus 4?
Negative 9. Negative 9.
Negative 5 plus 4. One's negative, one's positive, so we subtract, so negative 1. So the other answer that you could get is negative 1. And if you check your answers, you put the 9 in here for the D. 9 minus 4 is 5. 5 squared is 25, so that works. If you put negative 1 in here, negative 1 minus 4 is negative 5. Negative 5 squared is positive 25, so that works. So you have to be careful. If you do put the negative answer in, be sure you get the right one. So this one is not actually positive or negative 9, but it's going to be a positive 9 or a negative 1. Okay. Next one. We want to solve for E. So let's start with the basics. We'll circle our variable, draw our line, and then we need to figure out what's being squared here so we can put a box around it. So what is being squared here? What's that square on? It's on the parentheses, right? So since it's on the parentheses, this whole thing here is part of the square. So I'm going to put my box around all of that. Now the reason I do that is now I can look to see what needs to go first. So what do I need to get rid of first here?
The negative 3.
The negative 3 here, and what else? The other 3, the divided by 3, right? So these two 3's need to go before I can do anything with the square. All right, which one should I get rid of first? The divided by 3 or the minus 3?
The negative.
Okay, we'll get rid of that minus 3 by adding 3. And we'll add 3 on both sides. So when we add 3, those 3's cancel each other out. And what does that leave on the left side?
In the parentheses, both E minus 17 squared. And 3.
Okay, and on the right side? 3. Still have to get rid of this 3 first before we can do anything with the square, so we're going to do that by multiplying by 3. We're going to multiply both sides by 3, and when these 3's cancel each other out, what's going to be left? Okay, so everything that we had here is left except for those 3's. And then on the right side, 3 times 3 is? 9.
Okay.
All right, now the square is by itself, right? So can I get rid of this minus 17 now?
No.
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 Can I get rid of the 4 now?
No.
No. Those are both inside of the square. So I can't get rid of those until I get rid of the square. How do I get rid of the square?
Square.
Take the square root.
How can you square it though?
Take the square root.
I figured it.
We take the square root to get rid of the square, right?
Yeah, exactly.
So if we take the square root on the left side, we have to
Right side.
take the square root on the right side.
Okay. Oh.
So what's going to happen with the square root and the square here? They cancel each other out. So the square and the square root are gone, which leaves what?
Whole E minus 17.
And on the right side, the square root of 9 is
3.
3. Or it could be what?
Negative.
Could be negative 3.
Okay.
But again, we're not worried about the negative part. Okay, what next?
And positive 17 on both sides.
Okay, we're going to get rid of that minus 17. We're just solving like we normally do now. So add 17 to both sides. Those 17s on the left side cancel each other out, which leaves the 4e.
4E.
And then on the right side, 3 plus 17 is
19.
20. And then we need to get rid of that 4 by dividing by 4. 20 divided by 4 is?
5.
So we get E equals 5.